or on the right-hand side, and I'll go on the left. Hello there, Diego. Thank you, Casey. How are you doing this morning? Oh, sorry, I should say this afternoon.
It's pretty night here, you see. I'm doing good. I'm doing good. Thank you for having me here.
Oh, it's great to have you along, Diego. We've got a long history of working together on various events. And I know it's in the last few years that you've had a book out, which I believe is in an updated revision now. Is that the case?
Yeah, I just released a new edition a few weeks ago, actually.
Great. And just tell us before we get into your talk, what is the book about, Diego?
I can share my screen maybe so we can. Oh, the book is about machine learning and artificial intelligence. It's available on Amazon. It's self-published. It was an experiment. Pretty nice. And yeah, it's part of my introduction actually here. So this is
great.
the title of the book. Yeah.
Wow, that's wonderful. All right. Well, we'll let you talk about that when you get into your slides then. Well, thank you very much for coming along. Where are you joining us from today?
From Torino, from the northwest side of Italy.
So is it about 6:30 in the evening for you there?
Exactly, yeah.
Something along those lines.
Just finished my working day, yeah.
So you're on overtime for us today, Diego. We're very grateful.
Yeah. Just before dinner here. Where are you now, by the way? In the Chicago time zone or in Brazil?
I'm in Brazil still. I'm down in a city called Goiânia, and very pleased, but very bright skies outside actually at the moment.
Is it summer there now?
Yeah, I'm going to pass on the season. It's very, very sunny, but I'm afraid I couldn't tell you whether it's summer or quite what it is at the moment. It's always very warm. Anyway, Diego, it's great of you to come along. I won't hold you up any further. We're excited to hear what you've got to say. Sentiment analysis and AI in the world of speech technology is a fascinating area, and so we'll get your slides up, and over to you, Diego.
Thank you, David, and thanks everyone for joining us. So yeah, I will try to give a presentation about speech analytics and sentiment analysis, what I've been working in the past 2 years, among the other things. Just before entering in the technical details of the presentation, a few words about who am I. So I'm an engineer, I'm a technical passionate, and I've been working in voice over IP and open source for the last more or less 20 years. Recently, in the last 2 years, I've been working also on machine learning and AI, and in particular applied to the customer care space. Okay, so this is just about my book available on Amazon, and this is about a company I've been working for in the last 12 years. Actually, I'm now running the international operation of a largest group called Ingo. And one of our flagship products, it's XCALLY. It's a customer care omnichannel solution, and we've been able to integrate that with some kind of external tools about artificial intelligence. Specifically, you see here some example, Dialogflow, Amazon Lex, but via API, you can do much more with a lot of other tools. And machine learning, what I'm going to talk about today. I'd like to make a quick introduction about the world of machine learning and AI for people who are new, or maybe you have heard a lot of noise about AI. So let's start with a couple of pictures about what is not, in my opinion, machine learning and AI. So many people talk about, some people, let's say, talk about that as a way to decrease actually the human activities and human job and make that totally automatic. That's not really the main purpose in my vision. Actually, with machine learning and AI, you will see that you can even create new job opportunities, specifically for not just data scientists, but also data analysts, and a lot of other new job positions are opening in the world concerning this opportunity, actually. And AI machine learning is also not about strange cyborgs or robots. Just it's more about data science. So this is a sentence that it's becoming famous. Like it's not who has the best algorithm that wins. So not who has the best programming, but who has the most data actually has the advantage today in this kind of world. So up to some extent, machine learning is a subset, okay, of a big data science and AI world. Just like in the industrial evolution, we try to simulate physical tasks with machine. Now we are trying to simulate cognitive abilities, predictions, what our brain can do with machines. And yeah, machine learning is part of that. It concerns most part of try to get information from a lot of data, try to make some correlation, find patterns inside the data, and get some predictions and get something smart about that. So there are several types of machine learning. What I'm going to focus today is what it's called the supervised learning models. Okay, so I will not talk about reinforcement and unsupervised learning, but just supervised learning. And what's that about? In the supervised learning, we have some data. We know about those data. So suppose that we want to recognize some images. In this case, you see picture of digits, handwritten digits, and we want to be able to recognize what's inside the image. So if this is the number 504, whatever you see here, so we have a database in this case of data that we know about. Okay, so we know that this is 50 and so on, and we try to teach to the machine how to recognize this pattern. So there is a training process where we try to build a model with data that we know, also called labeled data. So we try to build this model, fit the model, adapt the model as best as we can. And at the end of the day, we are going to test this model with other kind of data in order to see if the accuracy is good. And whenever we find that we are satisfied with the results of this model, so the accuracy and the performance is pretty good, then we can use this model to make real prediction. Okay, so in this case, what I'm going to do, I'm going to feed the model with a new image I'm not aware of, the machine is not aware of, and of course the model is supposed to make the right prediction. So this is about supervised learning. And I will show you some example here today about speech analytics, sentiment analysis, and voice recognition using some supervised learning model. The first thing we need to do when we want to make some speech analytics or sentiment analysis, so we want to understand the sentiment of a conversation, for example, we need first of all to convert the conversation from a speech, from a voice to a text. So we need to make some speech recognition. There are plenty of speech recognition engine available in the market. This is an example of speech recognition engine, how it can work. So just like before, we got some voices. We know about those voices, and we try to build a model to recognize those kind of voices. So what we do is, this is a little bit more in depth, technically speaking, but I will try to put it simple. We are trying to here to map the voices with what it's called features. So features are data, numbers that are going to identify the specific voice that we want to predict. So just like you saw before, we're going to build a training model. So we're going to fit the model, to train the model with the voices that we know about. And at the end of the day, we get our model ready to be used and to make real prediction, okay? You can find this example on the web. It's a database of 2,000 recordings of real speeches. This is very simple. We're talking here about just digit recordings. So you find here on GitHub, on this link, the 2,000 recordings. 4 speakers recorded these recordings. So you have 500 recordings per speaker. And we are going to use this voice, and you can use this voice to build your speech recognition engine. Very simple to recognize only one digit. So if I play 1, 2, or 5, or whatever it is. So this is the a way to do that. The first thing that we are going to do is to feed our training model with the voices, the 2,000 voices you saw here. And in this case, we use an algorithm called MEL frequency acceptor conf coefficient. I'm not getting too much in detail about that. It's just a way to chop the voice, apply some technicality like power, spectrum, density, and discrete cosine transform. And then I get here the 13 features in this case. So for every frame of the speech, let's say I told 5, the number 5, I'm going to have 13 features mapping this specific voice. So what we're going to do here is we take these features, we pass these features as an input to a convolutional neural network, who is going to, let me say, put it simple, simulate our brain. And this convolutional neural network will be trained, okay, with those 2,000 samples of voice. At the end of the day, I will have my neural network trained with the optimal parameters, and I will be able to use this network to predict new voices. Okay, so this is how the model is trained with several kind of iterations. And the more iteration, the more accuracy I get. So this is good. And I can use this model to recognize simple digits. Okay, so we have just now built a simple model to recognize simple digits. Of course, in the real world, things are a little bit more complex because we need to recognize often full sentences, not just digits. This is an example of code. You can use, I use normally Python to do that, but you can use other specific languages for machine learning, R, Octave, MATLAB, even JavaScript if you like. There are plenty of opportunity. And you can use several kind of open source environment to work with that. Jupyter Notebook is one of the most used. Keras is a set of library pretty much useful in the neural network space. Google Colab is another good tool that you can use, but there are many. Of course, there are also challenges in this procedure. First of all, you need to not just to build a good algorithm, a good model, you also need to have proper data. And normally it takes a lot of pre-processing of the available data that you have. In this case, you saw that I used 2,000 voices, but those voices were properly trimmed. They were properly cleaned. So the best quality you can have for the data that you are going to use for the training phase, the better it is. In the natural, if I want to create a natural language speech recognition, then I need to use something a little bit more complex. I'm not going to use a convolutional neural network because in this case, it's important also to use something with memory. So whenever I want to recognize a part of a sentence, what has been pronounced before, it's very important. So it's important here to have some algorithm with memory. So for this reason, what it's normally used is some kind of, it's called recurrent neural network. Those are algorithms that keeps memory of the past, or something else like hidden Markov model, a state machine, able to use memory as well. So suppose that I was able to recognize the voice. So I converted a voice speech into a text. And now I can use a test in order to evaluate the sentiment of this conversation. If it is positive, neutral, negative, the level of positive or negative. This is pretty useful today in many applications, okay? I'm more related to the customer care space, so I know that many customer care today are using this. You can imagine that customers care, a contact center today has a lot of data available, especially if they are able to record the conversation, being that chat or voice. And with all those recordings and conversation, you can do some analysis of the conversation, try to understand the sentiment, the mood of the customer, and try to improve your customer service. Or maybe you want to do some specific marketing campaign or based on the content of the conversation. So the applications are really a lot. This is an example of the sentiment analysis interface that we have developed. And again, in this case, also in my example, I'm going to use a recurrent neural network because, again, the memory is important if I want to recognize a full sentence inside a test. And what is going to happen here, I'm going to use Keras, a library, and the embedding function of Keras. What does it mean? What I'm going to do here is to map each word with a vector. So suppose you have a text of a conversation. What I'm going to do is to map each word of a conversation to a number and then to a vector. And then I'm going to use this vector inside my recurrent neural network. Okay, so there is the initial phase, the embedding phase, mapping of each conversation to a set of vectors. And then I'm going to feed the LSTM is simply long short terms memory. It's a recurrent neural network and then a deep neural network here. And at the end of the process, I will have my prediction if in this case, the sentiment is positive or negative. I'd like to play a little bit of demo for you now, if I still have a few minutes. What I can show you here is the Jupyter notebook I'm going to use. This is the neural network built. This kind of sequence code you see here. I'm going to use Keras. So the first thing is the embedding procedure. As I explained it to you in the embedding, we are going to vectorize the test. And then I'm going to use 2 layers of long short terms recurring network. And the dense is simply a full connected neural network to do that, okay? So what is this about? This is about the phase where we are going to train the model, okay? We're going to build and fit our model the best that we can with several kind of iterations. The iteration here are epochs are 20. And you can see here, each interaction is trying to improve the accuracy, okay? So the accuracy is this chart. And at the end of this process, I should have a model quite good to feel the sentiment of the conversation. So I save my model here, and then I will use the model later for my predictions. So now in this, what is called inference or prediction, you see here I do a very simple example with a couple of conversations. Let me show you. Okay, the first one is, okay, very good. I appreciated the good service. So this is supposed to be a nice conversation. The sentiment is supposed to be positive. And the second one, really bad customer service, blah, 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 is supposed to be negative. At the end of this coding, you will see that this value is 0 for negative and 1 for positive. Okay, so if I output, the first conversation, which is the index 0 here, is supposed to be positive. So let's run the code here in real time and see what's going on. It takes a few seconds now. Okay, you see the sentiment is positive because the value is 1. And this is the output of the neural network you saw before. And I have here the probability of the conversation to be positive and the probability to be negative. So it's more positive in this case. If I change the index, I put 1, and it means that I'm now trying to analyze the bad conversation here. So the sentiment here is supposed to be negative. Let's try to run code and see what's going on. Yeah, it's unbelievable, but it worked. I don't know if James Barry here, it's here, David, but
if it's working, it's not that dangerous, Diego.
It's not that dangerous. I'm sorry.
Or is it a contender for the Swan Prize? It looks easy, but really there's a lot of complex moving parts.
Yeah. Last thing I want to show you is a graphical interface, a little bit better than the full coding. What we have here are the recordings, and I have two kind of recordings here, one positive, one negative. See, if I take this is voice recordings. And if I take the transcript here, the first thing that I did here is to convert voice to text, you see, okay? So those are actually, those were real voice recordings converted to text here. So again, this is positive because you see, it's very simple. And the other one is supposed to be negative as well, okay? Just an example of web interface to do the same things that you saw just here, okay? Let's get back to my presentation. I think we are almost done. We saw, to wrap up, just a couple of things, how to use machine learning and some AI training models to build a simple speech recognition, so to convert a voice conversation to text. And then we use the test and the conversation content with a recurrent neural network, machine learning, quite complex, but very well used today, algorithm to predict something more about the sentiment of the conversation. And that's all. That brings me to the end of my presentation. I'd like to thank you, everyone, for the attention. And if you have any question, I'm here available or later as well.
Well, we'd like to thank you, Diego. Thank you very much for coming and talking to us about such a fascinating subject. You know, who would have thought we'd come to the point where we can tell not only what is being said in terms of speech recognition on an utterance, but we can tell the way it's been said. And of course, with voice biometric, and also tell who is saying it in a small enough sample. So it's very fascinating. There is a question in the chat. If you have a question you'd like to ask Johan, please raise your hand. But meanwhile, Johan asks, do you make your transcripts automatically, Diego?
Well, yes, we have such kind of a transcript in XCALLY, and you can do that automatically if you want for all the voice recordings, or you can select just specific voice recordings you want to transcribe first, so convert from voice to text, and then analyze the text to get the sentiment. Yeah,
and I would add just as a general thing about your presentation, you hit many nails on the head there. The AI technology is really making a big difference in the area of customer service, not only from sentiment analysis in terms of looking at both the agent and the caller and whether things are going positively or negatively, but of course, as you also know, you can do the audio mining, looking for keywords and phrases, and also quality control. You know, if everybody is meant to answer a telephone and say, hello, welcome to Diego's company, you can mine for that using AI bots and things, and pick out the calls that don't say it and invite those people in for staff training opportunities.
Yeah.
So
other things that you will be able to do, very much interesting in terms of AI, is to try to find the best way to get in touch with the customer. Okay, so we are specialized in omni-channel, and during this pandemic situation, especially, you saw that there is a change in most part of us is working either from the office and from home. We want to be able not just to make voice conversation, but chat conversation or any kind of other video conversation. Actually, video is getting its momentum as well, and it would be very nice if I can use the best kind of channel to get in touch with another person or a customer in the customer space. This is very important, and AI can help you to identify, okay, in this moment, let's get in touch with this customer via message, or let's make a cold call or something like that. And there are companies working on that as well.
Yeah, that can have a massive effect, because if you reach people over the channel that they're most likely to like, you're off to a great start, aren't you? I see Sobo Max has raised his hand. I'm going to come to you in a moment, Max. Before I do that, I'm going to do two things. Number one, say hello to LiveU from the Open SIPS project. Good to see you in the room, LiveU. And also note that Ryan has asked a question. He says, how does your speech recognition compare to Amazon's SR SpeechRec API and Google's SpeechRec API, and which technology are you using underneath there, Diego? Is it entirely your own, or are you using somebody else's technology?
No, I must be honest. I'm not selling speech recognition. There are huge companies they are doing that. I'm just using external API of many speech recognition engine that we find on the market. Some of them are local, because one of the challenge of the speech recognition in the past is they work pretty well with English, but if you need to talk, I don't know, some very strict, well, Italian is okay now, but some Asian language and dialect, it's a little bit challenge. So I needed to use, for example, a specific voice recognition engine for a customer in Russia, and different from another in Malaysia, for sure. And so about the question, yeah, and there is not just the big vendors you have mentioned. There are others, smaller companies, and specifically in some domestic market, they can be useful because of specific languages.
Yeah, so you can use the best of breed for a given language. Okay, I note that Miguel has asked a question in the chat. We'll come to that. We got Johan saying he used to work for L&H, Learnout and Houseby, back in the day. Not heard that name for a little while. But Sobo Max, let's come over to you with your question.
Hey, thanks, David. Thanks, Diego. Nice presentation. I was just curious from the practical perspective. What kind of error rate do you get on simple task of numbers recognition, like those set you trained on? What kind of model you get after that? Have you tried to?
Well, in terms of speech recognition, now the engines that you can use are pretty accurate, I must say, especially again in the main most famous languages, English for sure, but also some other languages. The error rate is very low now. If you use the Google one, which is good in my opinion, the error rate is very
yeah,
low.
but if you run it in house, have you tried to run your own models on or are you
yeah. So that depends on the context. So if you don't have a specific context of the conversation, so you are just speaking just like us about everything, it's more difficult. So the error rate can rise a little bit. But in many cases, I don't know, if you are working for a speech recognition to recognize customer calling for the bank account information, or so in that case, the language that is being used will be very, very much focused, and the alphabet and the vocabulary will be restricted. In this case, the error rate will be very low. And this is about speech recognition. But you can improve the situation now. Instead, this is the big difference, in my opinion, from the past. even if you have a higher error rate, now with AI, you can train the model. So the more data information you have, the better performance you will have. And this is the power of AI. And also in the sentiment analysis space is like that. So in the sentiment analysis, the error rate is higher, in my opinion, not just because of the algorithm, but because it's a little bit more challenge also to
task is not very
make the
well
labeling.
defined.
Also to make the labeling. But the good thing again is that it requires some work. It's not that simple, of course, but you can train the model and get better performance.
Okay, thank you very much.
Yeah, thank you, Maxim, for that question. Thank you, Diego, for the answer. Just two more before we cross over to our next speaker, to young Dan Christian Bogos. Miguel asks in the chat, he says, these days, of course, we do have video chat for customer service. Could we apply the same principles you've just been talking about to analyze or sentiment analyze video calls or video meetings?
Yeah, we have some idea about that. We did some just experiment. I think we can do something, and that's a nice kind of application. I'm not seeing that much now today, but many companies are working on that. So the idea here is to recognize the sentiment from a facial expression. So yeah, definitely this is something that sooner or later we will see.
Okay, and
I'm not seeing that. It's maybe a good suggestion for SignalWire and Cantina as well.
Okay, yeah, thank you for that, Diego. One very last question, and that is this. You were looking really retrospectively at doing sentiment analysis based on recordings, I believe, although it's not a big stretch, and I think people are already doing it in real time, where you can do that analysis. So my question to you is, how close are we to be able to detect whether people are ready to buy things in a conversation? So, for instance, an agent could see some kind of little dial on their screen, and when it goes into the green, they say, okay, shall we go ahead? Are you ready to give me your credit card number?
Yeah, I've seen some concept about that, to do that in real time. There are strategies requiring, of course, good processing power to do that, but I'm starting to see something like that. And so we are not that far, in my opinion, to see something in production about that.
Okay, Diego. Well, thank you very much for sharing your wisdom and giving us that presentation. We really appreciate it. A big ClueCon.
Thanks for having me here again. It was really a pleasure.
A big ClueCon thank you to you. All the best. Bye for now. And
ciao, bye-bye.
Ciao. We'll fetch up young Dan Christian Bogos. Hello there, Dan. How are you doing today?
Hey, David. Hi, everybody. I'm doing great. Thank you very much for having me here. It's a wonderful event, and considering the lockdown in the mountains, which I did for the last half a year, maybe, it's really good to escape out.
Great stuff. And I know a lot of people are just staggered that even though we're running 2 ClueCons this year, we can get such high quality speakers to get involved, including yourself, Dan. And you're a friend.
I appreciate it.
A friend of ClueCon. It's spoken many times. And this time, I believe you've got a presentation for us along the lines of quality-based routing. But before we get into that, Dan, tell us a little bit about that amazing job you had. I think it was either last year or the year before, and you went to some amazing exotic place, didn't you, to do an implementation?
Oh, yeah. So, yes, I like to do this kind of, I think I prefer this kind of work to do in exotic places. The one I think you are talking about, it was in Bora Bora. So I went there, paid by the company to do work. So I think, I don't know what can compete to that. The money, I think, didn't matter at all there. So it was almost for free, but just the idea to go and have you work there, it was fantastic.
Incredible stuff. And I think you had a bit of free time afterwards to go and have a good look round, didn't you?
Yeah, of course. I made my own free times, because the work there, it was like 5 days, and altogether I spent 2 weeks there. So I made sure I have my exploration time there.
Top class. Well, again, I know in common with Diego, you're into your evening there, and I can see the dark through the window. So
yeah, same time as Diego. Yeah.
Yeah, I will step to one side and ask for your presentation to be brought up, Dan, and hand over to you. Thank you for joining us.
Yeah, thank you also. Great. So, as you probably know from agenda already, I'm here to talk about quality-centric routing or routing, depending on whether you are in Europe or US, using CG rates. I think, okay, I was muted for a second. Okay. So we are located in Germany, in Bavaria, over 13 years of experience with architecting voice over IP environments. So we have dealt with both wholesale and retail in our, let's say, work life. About CG rates, it's a real-time enterprise billing suite. So it's more like a framework than a real billing. It serves more as an engine in someone's network, depending on the needs and the profile of billing you need to achieve. You can use it as a what people are calling OCS, this online charging system. You can use it as a routing engine for getting your LCR up. You can use it as a stats engine for building up stats in your own network, or you can use it as resource controller or fraud mitigation software. So it all depends on the project you have behind. We treat them all equally. They are all standalone subsystems of CG rates, and you should be also very well able to combine them. So you are you can put them either together or in separate microservice and stuff like that. It should be non-intrusive, so it communicates with your switch or your router or whatever you have in your network. It's all open source software. It was born in 2010. The first sources we published in 2012. Full sources are available on GitHub. It is written in Go. We were one of the early adopters of Go language. When we started with Go in 2010, it was weekly release, so not even first stable out. We are working with multiple branches. So we have release branches and master. We run master at production sites. So the difference between release and master is that the master is still getting features. The release branches are not anymore. Working with telecom, it's really hard to have environments being upgraded. So this is why we decided to go with releases being unlimitedly supported. We have no add-ons in private repositories. We get a bit insecure by hiding software from community, because community really helps us a lot on finding problems and especially security issues. We have really consideration for community. It's performance oriented. As an OCS, as primary, we are targeting very fast speeds. Our internal APIs were load tested at about 50,000 requests per second. So of course, it depends on which components you use in which configuration, but you should just know that we are really optimizing a lot considering performance. Everything is asynchronously. We use what Go or Golang it's calling microthreads. Test-driven development project. We have just counted about 67% of coverage of the code, and the core libraries are hitting close to 100% testing. So it's really very well, and we take very much care about testing the software, considering it's a billing component. A bit about the code. We started, as I told you, we published the code in 2012. The funny part is that our first ClueCon was in 2013, when we really started being serious with the software. Since 2013, by the time we came to ClueCon, we never had any month of inactivity. So worst months were at 25 commits a month, which is close to 1 commit a day. If you look on our 12-month summary, you can find around 2,000 commits. If you look on 30-day summary from today, it's 250 commits. So it's quite some heavy maintained software. We are also getting close to our idea about version 1.0. We had versions, but we didn't count them as version 1.0. You can see here a lot of testing going on, and most probably the situation now will calm down as soon as we finish with all the changes which we are planning. I don't want to go too much into these details, because I tell them all the time. I said I put an overview of the system here, just maybe people who want to read it later, they can do it, because for today I prepared a bit more practical things, so you can benefit more technically speaking out of my talk instead of the theory. I also like ClueCon, by the way, because it's more technical oriented than other conferences. So me coming here, I don't want to ruin it, and I want to follow the lead of the conference. Just a bit about the architecture of CGRates. On the left here, you can see interfaces towards outside. So these interfaces we use when we talk to different switches, starting with diameter agent, which is the preferred component in mobile world, LTE, stuff like that. Radius agent, which we use when we talk to Wi-Fi, because we handle authorization. All these are generic, so you can configure them in the way you need it. HTTP agent, again, starts being popular in 5G now. DNS agent for stuff like enum routing, SIP agent for SIP redirects, Asterix, FreeSwitch, all these were written by us to interop with the open source components. Camaillio agent, here you cannot see, but we have a native, not maintained by us, module in OpenSIPs. So OpenSIPs can talk to CGRates through a native module, and an event reader service, which is dealing with importing CDRs out of files, CSV, JSON files, also importing out of SQL, various flavors of SQL, various Kafka, RabbitMQ, and all this which are popular these days. Here you can see our main, our core components, which is the rating and accounting, CDR server, mediation service by attributes, charges for multiple simultaneous charging. For example, if you have distributors, customers, suppliers, so you want to for each CDR to calculate the price for all of them, resource for resource control and management, routes for generating routing, stats for generating stats, and thresholds for monitoring your network, including fraud mitigation. Some modules outside, some dispatcher to increase the high availability or the load balancing in your network, scheduler to execute scheduled tasks like top up automatically at the first of the month for your users, event exporter for sending the things out, and so on. What's new in CG rates? We have introduced a SIP redirect. So we are also a SIP server, but just for redirects. We don't plan doing anything more because this is all we need for a routing server. We have support UDP, TCP, TLS there, and it's totally programmable, so you can interact with the core inside. As applications for the SIP agent, prepaid control, steer, because we also support steer shaken, password, IP address authorization, call parameters, call routing for supplier selections, call parameters for maximum duration, steer initiate, CLI control, destination formatting, number portability, and emergency services. So all this could be on top of SIP agent. These are also available in all other agents of ours. Steer shaken, it was also added recently because it starts being popular in North America. We do this type of origination destination checks at the station level. We can handle authenticate and initiate. We have tested it's interoperable with both Kamailio and OpenSIPs implementations, and it can be SIP and what's interesting, API based. So you can also use it as an API server to generate authentication header and initiate identity and stuff like that. Event exporter service is interesting because you can do rating queues for getting the CDRs almost in real time from your switch, directly rated. So you don't have to store the CDRs inside CG rates, but just pass the CDRs through the system. And then you get them out, being pushed out or written in the file or via AMQP, via Amazon S, Kafka, S3, and so on. So a lot of options there. Routes, it's also a new subsystem. It supports a lot of routing strategies. For example, weight-based, least cost, high cost, QoS for quality-based, REAS for resource ascending, REDS for resource descending, and load-based. So you can choose from a number of different routing strategies. Plus, you can combine them with advanced filtering, like even when you have, as I will show you, least cost, you also check the quality. So average call duration needs to be higher, or average success ratio seizure ratio, or how you call it, needs to be higher than some percentage. You can have also simultaneous routing profiles with prioritization and so on. What's on the roadmap here? Contact center routing, maybe a bit of machine learning inside, because we do support stats. And it's a standard interface for interconnects. So we plan standardizing the way big people are interacting. Some V1 roadmap, we are rewriting the main components, rates, accounts, and actions, and we plan introducing a PCRF, which is mobile-related stuff. Free switch integration, it's done in 3 different ways. First, and the most preferred, is real-time via mod event socket. We have published one of the early libraries. As you have seen in 2013, there were not many options in Go. Now you have very good libraries to interact with free switch. Our one was published in 2012, 2013. We handle 3 events with free switch: channel park for authorization, channel for starting the debit loops, and channel hang up complete for debit loop stop and CDR generation. We are using show channels for synchronizing up now and then the channels between CG rates and free switch to make sure that we are not running stale calls. We also force disconnect the calls from CG rate side via hang up command when if the bundle is faster debited. regarding the next, we can do authorization and routing via the SIP agent, which I just told you about. And offline, we can work with mod.json CDR for postpaid, which is close to real time, because mod.json CDR uses also channel hangout complete to publish the event. And mod CDR CSV we can also do via asynchronous CDR processing via ERS module. It can be used, for example, for billing assurance. If you already have a billing system and you want to double check it with CG rates or see about the compatibility. So I have here prepared some, one moment. Some calls here. So to make sure I start, so I have installed FreeSwitch out of files which you have at via apt repository, the latest 10, I think. So it's 1.10, and I also installed CG rates via our apt repository. Again, this is from yesterday, so it's everything pretty up to date. I'll restart CG rates just to make sure we start fresh, and I'll fire up my preferred API. Because CG rates is all API based, I will use Postman to communicate to CG rates. So before starting everything, I need to load my files, because CG rate starts empty. So I need to I need to put all the routing and to set up everything for live calls. I have this, by the way, this will be published on GitHub. It's in our tariff plan sample, so you can anytime use this tutorial and test it at home. So now I have loaded from 2 routes. Remember this path, and I will try to make some calls. Before making that, I'll put a sniffer between CG rates and FreeSwitch, and a sniffer on internal CG rate APIs calls between modules. Postman should tell me what I'm targeting to achieve. So I have now a routing profile. One moment here. Which, let me make it bigger, which tells me the following. If I'm dialing, filters are totally dynamic, so you put based on the events you generate with FreeSwitch. If I'm dialing from my account 1001, which is the account of FreeSwitch, I will get as in my routing profile based on priority. This is the simplest routing and the classical way to route calls based on prioritization of your gateways. I will get the vendor 1 with priority 10 and vendor 2 with priority 20. So vendor 2 will be always preferred, and vendor 1 will be used as backup. However, vendor 2 is only getting into service when the balance of my account 1001 is higher. You see, this is a typical filter like we use also in Mongo, greater or equal than 10. So if I look now first my balance, let's say my balance for account 1001, I have loaded via this low tariff plan from folder. I get it as 10. So if I'm right, when I do now the call, I should be getting, based on the route profiling, the vendor 2 as as first and vendor 1 as second. So let me just fire up a call from Zoiper. Let me just replicate one call I did. So I'm making now a call. I answer it. The call takes, I don't know, let's say 5 seconds. I stop it at 5 seconds. And now I will look at CDRs. So I'm getting here, I should be getting 2 CDRs. One is with a category vendor 2 because my vendor 2 was selected. You see, it also has a price from the vendor 2, which is 0.00498. And the standard call will cost me about 60 cents. So I'm safe. I'm doing quite some profit over here. Now I look at my balance because I have done a call and I have taken some money out of it. So 60 cents. RALs, get account again. So I have now 9.4. Based on my routing profile, I should not get any more vendor 2 because my balance needs to be at least 10. So I'm doing now my second call. Okay. To extension 1002. I answer it. Again, 3 seconds. I'm looking now again at my CDRs. Now I should have 4 CDRs because I have one for my supplier, one for my call. And if I look at the last, I see I'm going over vendor 1. My call is more, it has different price, but I have correctly not hit vendor 2, even if it has higher priority, just because my balance was not high enough. So it was not having enough money inside. Now I'll show you some other examples of routing profiles. For example, this one has a routing strategy based on least cost. However, normally the vendor 1 is the one which is or vendor 2, whatever, the one which is cheaper. I think it should be vendor 2 based on the rating plan I'm configuring. But vendor 2 will only get into service if my statistic for vendor 2 has an ACD higher than 1 minute. So if I'm getting poor stats over vendor 2, even if this one is cheaper, my call will not be served by vendor 2 because the system looks at these stats and it sees that they are not good. And you see everything what you do, it's fully based on your own logic. So you can populate these things and bind them together without any hard coded. So you define how your stats are named. You define what are your rules to get your vendors into routing. Here, for example, it's looking at resources. So it's looking at active channels, and it says the active channels of my resource group 1 should be lower than 5, because if they are already sending me too much traffic, they are overloading the number of channels in use. So again, all this, as my talk assumes, it's oriented towards the quality. Another idea is pure stats based. So the other was looking for cost, but filtering out based on quality or number of channels in use. This one is purely driven by cost. So you can see here that it's choosing vendor 1 if it's choosing actually based on the quality of the 2 vendors, which is vendor 1 and vendor 2. And not considering, and primary when considering quality is what you define here from stats, which is average call duration. So if I'm now just simulating this, I prepared. So right now you can see it's ordering based on average call duration, because the vendor 2 has an average call duration of 6 seconds, and vendor 1 has an average call duration of 3 seconds, is putting priority on the vendor 1. Now, if I emulate a bit, and I'm sending some events, for example, some cost and some events, and I'm looking again on the routing, it might change or not. Now it's the average call duration 68 versus 34. If I'm pushing now some more stats concerning the vendors, I will get maybe, if I'm lucky, oops. You see, I got now vendor 1. So I think it's changed from the previous, just because vendor 1 has now average call duration of 68 seconds versus vendor 1, which an average call duration of 62 seconds. So you can do many combinations based on different things as just least cost. You can also use least cost with filters. This one is, for example, purely resource driven. So I'm looking how many active channels the vendor 2 has and how many active channels the vendor 1 has, and I route based on the number of active channels in use by them. So I will stop now here. We can talk, I think, days to come on what various possibilities you have here. But the good news is that the old least cost is close to be dying, and the combinations now of routing are starting to be more popular. I also tried to make it in time.
And you did just about there, Dan. You've come in at just a couple of minutes over, and I think we started a couple of minutes late for your session, so we can't complain about that. Thank you very much.
Thank you also. I appreciate it.
You're welcome. We're grateful to have you, and a man of expertise in the realm of billing, and so I don't want to let the occasion pass without asking if there are any questions for you. We've got you up on the screen there. Any questions for Dan before we finish this session and hand over to Abby? Okay, not seeing any. There's a lot of furious debate about codecs going on in the chat, which is not necessarily connected with CG rates, but that's a separate thing. Okay, Dan, we're very grateful. Thank you so much. And thank you for being a friend of ClueCon. We always appreciate your participation. I have many happy memories. I've been on the boat trip off to the lake in Chicago with you and other industry colleagues. And we wish you well. And I hope you'll be participating in August ClueCon as well.
Always a pleasure. So many thanks for inviting us here.
Okay, great. Thank you very much, Dan. We'll bring up Abby now, because I think she's got some exciting news of one sort or another. So what have you got to tell us about this time, Abby?
Yes. Well, like you mentioned, we're definitely having ClueCon this August. We're going to do everything we can to be able to have it safely and in person. But if we are having to be virtual again, that's okay. No matter what, August, same time, ClueCon is happening. So make sure to check out the website for updates and follow us on social media. We post a lot of updates on our Facebook and on our Twitter. So make sure you follow us there to get all the scoop on what's happening in August. We do have some workshops coming up. The next one starts at 1 o'clock, so in a half an hour. We have a Janus workshop, a Homer workshop, and a Free Switch workshop. So check out the schedule at ClueCon.com. to remember exactly what times those are, but don't forget to show up for the workshops. And then stick around afterwards. We're going to be hanging out from 5 o'clock Central Time until 6 p.m. Central Time in the lounge. Of course, if you're not interested in all the workshops, this space is open to hang out and talk and do whatever you might. So feel free to hang out in the coffee shop. Feel free to hang out in the lounges while you wait for the workshops.
We've even got a hallway track, Abby, haven't we?
We do. Remember the good old days of being in a conference and you run into someone in the hallway and then you happen to have the most intelligent, insightful conversation of your life on accident just because you ran into someone cool in the hallway? Well, you can still do that here at ClueCon 2021. So feel free to check out the hallway and see who might be hanging out there. You never know who you're going to find.
And before you carry on, I just want to point Dan. I think Dan's still in the room. Dan Christian Bogos. I just want to point you to the chat, Dan. There's a question for you about having rate sets defined. So with that, I'll hand back to you, Abby. I just didn't want Dan to miss that question.
Oh, okay.
Yeah. I'll look inside. Thank you very much. Hi, Abby.
Hi. Great. Let's see. The only other things I really have to say before I give away my last $100. So everybody cross your fingers. Ooh. But before
Ryan's doing some drumming there. Can you see in one of the frames?
Ryan's always really pumped about the gift cards. For those of you who weren't there yesterday, we are having a Coder Games for the August ClueCon, and they actually have started right now. We're sending out kits to everyone who's interested that include an Arduino board, although coding is not necessary to play, in which we'll issue 6 different challenges that will help you get off an imaginary deserted island. So we're going to have to survive a plane crash, find clean drinking water, find shelter, escape the island, send out some distress signals, find food. So it's going to be a lot of real world challenges with lots of different ways to solve each problem. So if you're interested in that, go to cluecon.com/codergames and or come hang out with me in the deserted island room during our break, and I can answer any questions you have and help you sign up. So that's going to be a lot of fun. The sooner you sign up, the sooner you can get your kit. Although if you don't want to get a late start, we will be putting everything online. But we have some goodies. You know, whenever I'm involved, there's always prizes. So the sooner you sign up, the luckier you're going to get. And I don't want to spoil anything, but that's all I'll say. So signing up sooner is going to make you a lot happier, I promise. So if you're interested in that, go to cluecon.com/codergames. And with that, I have an $100 Amazon gift card to give away. Drum roll, bell roll. And the winner is Patrice Fournier. Patrice, are you in the audience?
He's going wild in there. And he's got a great t-shirt as well.
Woo! And of course, meet us in the lounge at 5 o'clock and we can all heckle all of the winners and see if maybe they'll get us something off Amazon.
Sounds like a good call. Thank you very much, Abby. Is there anything else you'd like to tell us before we go to a break?
Nope, that's all. I'll be in the deserted island if anyone has any questions about the Coder Games.
That's brilliant. Thank you very much. We're going to go to a break now. We're back at 1 o'clock Central Time with a great workshop all about Janus from Lorenzo. You saw him earlier talking about NDI, and he's got a workshop devoted to Janus, and maybe he'll be mentioning NDI in there as well. Do tune back in for that in the Janus workshop room. So it's not going to be here in the main event room. It's going to be in the Janus workshop room at 1 o'clock. So we'll see you there. And as Abby said, lots of places where you can hang out and chat to each other and anybody you want. So thank you very much. We'll see you at 1.